Welcome students, welcome parents, welcome to Concept Clarity. This is our third session on magnetic effects of current. In today's session, we are going to cover the extension of the second session. In the second session, we have studied when a current is flowing in a straight wire. Now the same wire we'll bend in a coil like a circular loop. And then we will use the same circular loop multiple times to create a solenoid. So let us understand the magnetic effects of current in a circular loop and a solenoid in today's session, which is the third session. Okay, so this is a solenoid. You see here, sorry, not solenoid. This is a circular loop, right? This is like a wire, a straight wire, which is turned as a circle. It is turned as a circle, right? It is called circular loop. So here also we observe magnetic field. Magnetic field at each and every point along the wire we have observed. It's like you can imagine it like the circular coil. You bring it back as a straight wire. It is nothing but the same wire. So you'll still have the same magnetic field around the wire, right? So magnetic field will appear like this. In the experiment conducted, we pass through the current in this direction. This is the positive sign here, right? And the negative on the other side. So the direction of the current is upward. So if I show upward, that means the curl, basically this side is inward. This side is inward, and here it is outward. Similarly here on the other side of the conductor, we will point downward, right? So actually it will curl like that only in this direction, right? It will be inward here, right? In the center it is always inward, and outside it is on the outward. Okay, so that means in the center of the coil, in the center of the circular loop, we have observed that almost the magnetic field becomes like straight lines. In the center they become like straight lines, right? If you observe here in the center, they appear like almost straight lines. Closer to the wire, the fields are closer to each other, so the magnetic field effect will be stronger there. Okay, so this is how magnetic field appears on a circular coil, right? In the inner side of the coil, the magnetic fields are inward depending on the direction of the current, or it can be outward if the direction of the current is reversed. But on the inner side, the direction of the magnetic field will be same. Okay, so this is for circular loop. Next, solenoid. What is a solenoid first of all? A solenoid is a coil of many circular turns of what? Of insulated copper wire wrapped closely in the shape of a cylinder. If you see here, there are many circular coils, and when you keep circular coils over and over each other stacked, it will appear like a cylinder, just like this. It will appear like the cylinder, but without the black core in the center. It will appear like a cylinder without the black core. You can imagine the black core also, right? But if there is no black core, it will still appear like a cylinder. So it's a many circular coils of insulated copper wire wrapped in the shape of a cylinder. Now solenoid behaves like a bar magnet itself. That means when you pass current into the solenoid, obviously there are multiple circular loops. So when you have multiple circular loops, there will be magnetic field in each of this loop. So the magnetic field in the center will appear like a straight line. They will appear like parallel to each other. Here in the center, I will take the blue indicator. Here in the center, they are parallel. And then far away from the center, they appear apart. Right? That means they are uniform in the center. They are uniform in the center. Okay. Now in this solenoid, if I place a soft iron inside the solenoid, okay, like this, here in the second diagram is shown here, multiple copper turns are shown, and in those copper turns we have put a soft iron. It may not be black in color. Mostly they are shining in color. Okay, they will be mostly like aluminum. Okay, so this, when you put the soft iron in the solenoid and the current is passed in the copper wire, that is a solenoid of multiple turns, then we'll see that this rod gets magnetized. It will become like a magnet. So this is a temporary magnet. It is also called as a electromagnet. That means only when the current is passing to the coil, the soft iron core will behave like a magnet, which is an electromagnet. And when the current is stopped, when the electricity is off, then the bar magnet will no longer behave like a bar magnet. I will share a short which will demonstrate this as well. Okay, keep on a watch, like and subscribe the channel so that you can see the short as well, which will demonstrate in live the solenoid and how it attracts the pins. And when I put off the current, you will see that the pins also get released. Okay, keep a watch on the channel. So I guess that's it in this particular session. In this session, we have seen circular loop and solenoid. We have seen the magnetic effect of the current in the circular loop and solenoid. In the next session, which is going to be our final session, which is the fourth session, we will understand the application of magnetic field. We will see whether magnetic field can create a force, and that force we can use to create all our instruments, whether in medicine or whether in our daily life for travel purpose. Okay, so stay tuned. Please like, share and subscribe.